Glad you can join me on this lesson as we'll be solving a question in physics involving velocity time graphs. So let's look at the question. A car slows down from a velocity of 40 meters per second to 20 meters per second in 5 seconds. It then moves with this velocity for 3 seconds and then comes to rest in 2 seconds. A. Draw a graph of velocity against time for the motion of the car. B. Calculate the retardation in the first 5 seconds, total distance covered by the car, and the average speed of the car. So let's first begin with drawing the graph. So we can draw our y-axis and then include an x-axis. So for the y-axis, we can divide it into 20 there first. Or let me just put 10 and then 20, and then you have a 30 there, and then lastly 40. So the y-axis will represent the velocity in meters per second. And then we can move to the x-axis where we have 2, 3, 4, not 3, sorry. Let's put 4 here, and then 6, and then we have 8, and then we can write 10 there. So the x-axis will represent the time in seconds. So let's begin with the first motion. A car slows down from a velocity of 40 meters per second to 20 meters per second in 5 seconds. So the 5 seconds is just between where we have 4 and 6. And then we can draw a line from 40 here to where we have 20, but it should end where we have 5 there. So you have your motion like this, and then it travels or it moves with this same velocity for 3 seconds. So for 3 seconds it will go from 5 to 8, to go from 5 to 8, and then it comes to rest in 2 seconds. Let's draw another line. So in 2 seconds it can end where we have 10 there. So we have drawn our graph. Let's now calculate the retardation in the first 5 seconds. So this is B, Roman number 1, finding the retardation. So retardation is just the negative acceleration. So if we find acceleration, the value for acceleration as a negative, it means that the car it is retarding or it is decelerating. So we can still use the same formula for acceleration, which is A equals V minus U over T. So final velocity minus initial velocity over time. So here, our final velocity, since the car is already in motion, our final velocity will be 20. And then our initial velocity will be 40 over the time, which is 5, equals 40 minus 20 minus 40, you have negative 20, and then over 5 there. 5 into negative 20, it is just negative 4 meters per second squared. So this is our retardation as in negative 4 meters per second. So what is the second part? The second part is asking us to find or to calculate the total distance covered by the car. So the total distance from where we started from, which is the 40 meters per second velocity, to where the time it is 10 seconds. So the entire journey, the total distance for the entire journey. So in order to calculate that, we have to find the area under the graph. So we can divide our graph into portions which will resemble certain shapes and then calculate the area of those shapes. So we can split it here. So here, the first one, we can name it A, and the other one, we can name it B. So the first one, you can, if you look at this, this is a trapezium, and the second one, it is also a trapezium. So what, in order to, so for the first part, its distance, we'll use the formula for the trapezium. So let's jump into the solving of the question. So B, the numerator 2. Let's write the, so distance A will be equal to 1 over 2 A plus B, and then H multiplied by H there. So let's identify our variables. So we have here it is the height, H, here it is A, and then here it is B. So from here to here it is, so our A it is 20, and then our H it is 5, and then the B here it is 40. So we can go and replace. We have 1 over 2. A, we said it's 20, plus B, which is 40, and then H, it is 5. So equals 1 over 2. 20 plus 40, you have 60. So what we have is 60 multiplied by 5 equal to 1 over 2. 60 multiplied by 5, it will just give us 300. 300 divided by 2. So you have 2 into 30 there, it will just give us 15, and then the 0, it will be 150 meters. So the first distance, it is in first distance, it is 150 meters. Let's find the other one. Distance B. We can write our formula again. We have A plus B multiplied by H. So for the other one, this one will be our H, and then A, and then you have B there. So H, it is 20, and then A, you have 5 from 8, so 5 minus 8, so our A will be 3, and then B there, B, it is 5 to 10, so B equals 5. You can go and replace 1 over 2. A, we said it's 3, and then plus 5. H, it is 20, the height. So we have 1 over 2 multiplied by 3 plus 5, that is 8. 8 multiplied by 20. So 8 multiplied by 20, it will just give us 160. So we have 160 there. 160 divided by 2, it will be 80 meters. So the distance for the second part, it is 8 meters. So in order to find the total distance, we can add the first distance and the second distance to have the total distance. So you have total distance, equals to 150 meters plus 80 meters. So this one will just give us 230 meters as our total distance. So we are done with the second part of the question. So let's look at the other part, which is the average speed of the car. So the average speed is just calculated as the total distance covered over the total time taken. So the total distance, we have it as 230. Total time taken, it is 10 seconds. Let's go and press there. So this one will be average speed equals total distance covered over total time taken. So we have our total distance as 230 meters. Total time, you have it as 10 seconds. So if we calculate, it should give you 2.2. Here remainder. So here it's just 23. It will give you 23 meters per second as your average speed. So we have come to the end of this question, and thank you for joining me. I hope you subscribe to my channel and see you in the next video.